All AP exams have some questions where they give you a bunch of reactions and some of their values, equilibrium constants or enthalpy changes, entropy changes, or even changes in Gibbs free energy. They'll say use these equations to come up with something new, this extra equation, which is what this one's about. Based on the information above, they give us these three equations. We'll need to know about the equation below. These can be a little bit confusing, but one tip that I can give you is have faith. They've picked these three equations, so they're going to pretty easily produce this final one. And it's not going to be that tough. So look at your desired equation. Here's the desired equation where you got this lanthanum. Here you've got this rare earth metal with a +3 charge, but I don't care. That's fine. I've never seen lanthanum used in a reaction before, but we'll just take it as it is. So we need lanthanum with a +3 charge as a reactant. Well, here's lanthanum as a +3 in a reactant, and there's one of them. So I'm going to use this equation just as it is. You can say, hey, that's it. This is an equation, and I'm going to use it just like it is. I'm going to use that to make my desired reaction. Leave that one alone. I'm going to look at the next reactant. I've got one carbonate. So I look at these three equations and say, okay, where's the carbonate? Oh, here's a carbonate, and there's one of them. That's good. But this carbonate is a product, and I need it as a reactant. Well, that's no big deal. I'm just going to take this equation. Now, you've got to take the entire equation. I'm going to make these products some reactants. And, of course, that means I've got to make sure that I've got my equilibrium expression again. And then this reactant here becomes a product. That means that puts my carbonate right here. Now, I'm not going to worry about the rest of this stuff because I have faith that things will cancel out. So if you flip a reaction around, if you're dealing with equilibrium constants, you're going to have to flip the equilibrium constant around. You're going to use this reciprocal because equilibrium constants are products over reactants. And if you put reactants over products by switching things around, you've got to flip the Ka. Had this been a delta H, a delta G, a delta S, you would just change the sign, because if a forward reaction is exothermic, reverse reaction is endothermic. So everything else, if you flip a reaction, change its sign. If you have an equilibrium expression, though, you've got to do an inverse. And really, right now, I'd say, okay, I've got one lanthanum, I've got one carbonate, I'm pretty well set, except there are these extra little things there in the way. How are these things going to add up? Because I've got H+, I've got H2O, and all this other stuff, and that's where the third equation comes in. It's going to clean everything up. You see, I have H pluses, and I don't want them in my final reaction. So here is an H plus as a product. That'll cancel out a reactant. If I take this equation, I'm pretty sure things are going to work out. And I think you'll see right now that I've got my lanthanum as is, no problem. I've got some hydroxide, but I don't want any hydroxide, but that's what this water thing comes from. And there's a hydroxide as a reactant. Here's a hydroxide as a product. They'd cancel out. This is just like doing a regular math problem. That's pretty good. Now I've got hydrogen carbonate. Well, I don't want hydrogen carbonate, but look over here. Hey, again, they've set things up so the hydrogen carbonates cancel out. So I've just got lanthanum, and here I got my product, which is fine because there's my product. Water, I don't want any water. Well, that's easy because this equation here that I picked up before gets rid of the water. Okay, let's see. What do we have? So far, on my left side, I've got lanthanum cation +3 and H+. But wait, there's no H+ here. Here we go again. Have faith. This H+ cancels out. So now the only thing I've got left on my reactant side is lanthanum and carbonate. Lanthanum and carbonate. The only thing I got left up on my product side is the carbonate. So if I combine these three reactions, I add them up, I'm going to come up with my desired reaction. Because these are equilibrium expressions, we're going to have to just multiply them out. If this had been delta S, delta H, delta G, we would end up adding them. So let me show you the final result. Here it is. To produce the desired reaction from the given reactions. So I've got lanthanum in my net reaction. All these other characters cross out except for my carbonate, which I needed. So it's beautiful. Remember, these things are going to work out. If you get the reactants on the right side and the products the right side, you've got it made. Okay, there we go. There's my explanation for adding reactions. Have faith that you can do these.